All right, so for our first example of circumference applications, we're just going to see if we can complete the entire table here. So, for instance, they give us the object a wagon wheel, and they tell us the diameter is 3 feet. Well, we know that radius is always half of diameter, so the radius must be 1.5 feet. Okay, and then to find the circumference, we just need to use our circumference formula. And again, like we learned yesterday, it is C equals pi times d, meaning circumference is equal to pi times the diameter. So if we're going to plug in for the wagon wheel, we know the circumference must be equal to, they tell us to use 3.14 for pi, so we can put that in. And then we're going to substitute in 3 for our diameter. And if you plug this into your calculator, 3.14 times 3, we get 9.42 feet, which would be our circumference. And our first row of the table is complete. All right, let's look at our plane propeller. So they tell us the radius is 24 inches. So to get from radius to diameter, you multiply by 2. So the diameter must be 48 inches. And that's what we're going to use in our circumference formula. So just like we did for our first example, we're going to write C equals, we're going to put in our 3.14, and then we're going to put in our 48 for the 48-inch diameter. And if we multiply those out real quick, looks like we get 150.72 inches. So 150.72 inches. All right, for our last one, we have to work a little bit backwards because they don't give us radius or diameter. They actually give us circumference, which we're going to start with. So we're going to go back to our circumference formula like we have been doing, but instead of plugging in for the diameter, we're putting 20 in for the circumference. So we're going to say 20, the C, is equal to 3.14 times, and then we don't know our diameter yet, so we're going to leave that as our variable. And we saw an example like this yesterday where we just have to divide by 3.14 like we're used to doing on both sides of our equation to find our diameter. So let's see. So if we put in our calculator 20 divided by 3.14, it looks like we get, it's a long decimal, 6.37. Looks good to me. So that's going to be our diameter in centimeters, 6.37. And then, of course, diameter is twice as big as radius. So if we do 6.37 and divide it into 2, our radius, must be 3.19, I think. That looks good. So 3.19 centimeters. So again, this table kind of activity is just asking you to use your circumference formula again, and just kind of apply that in a couple different ways to fill out the missing spots. Okay, so if you need to pause the video, get those down, and hopefully that makes sense where those are coming from. It's all related through this circumference formula, which we discovered yesterday through our measurements. All right, let's look at this second example. So we're going to look at a Ferris wheel, which has a diameter of 80 meters. So they want us to take the graphic and actually draw a diameter on it. So here's our center point in the middle of the Ferris wheel. And then again, diameter is from edge to edge through the center point. So maybe something like this. And it could really be any of like the spokes on the Ferris wheel. And we know that that's 80 meters long. Okay, so we've drawn our diameter. We want to think about how far a rider goes one rotation. So if you think about it, like, I don't know, maybe the rider's starting down at the bottom here in that yellow car. And when they go around, they make a full rotation and come back to where they started. Hopefully you're seeing after I highlighted it, that's circumference. So they're really asking us to find the circumference when they go one rotation around. So circumference is equal to pi, so 3.14, times the diameter, which we said was 80. And if we put that into our calculator, 3.14 times 80 gives us 251.2 meters. That's the entire distance they would travel if they went one rotation around. And then the last part says, well, what happens if they go 7 rotations? Well, it was 251.2 meters for one rotation. If we multiply that by 7, let's see, looks like we get 1,758.4 meters. And that's how far they would go if they were able to go around 7 rotations in one ride. Okay, for our last example, it's a perimeter question, which we're going to try to solve using this sort of ice cream cone shape type of picture. So let's break it down. There's 2 shapes in here. We have I'm going to do it in red, a semicircle, which is a half of a circle. And then we have, it looks like they tell us, an equilateral triangle. Okay, and again, this dashed line in the middle, we don't want to count that because that doesn't really count as perimeter. Perimeter is just outside. So they tell us that this semicircle is joined to an equilateral triangle that has side lengths of 12 units, meaning all of the sides in this triangle are 12 units. So this one, and even this dashed one, even though we're not going to count it. Okay, and of course I want to include this 12 that we're not going to count because if you look, it's actually the diameter of this circle. So we're going to use that to find the circumference. So let's plug it in. C equals 3.14 pi times the diameter, which we said was that 12. And that's going to be equal to, let's see, 37.68. But what we just got was the circumference of an entire circle, which would be like in all of this red, which we don't actually want that part. We just want the half of it because it's a semicircle. So if we take 37.68 and divide it by 2, let's see, it's going to give us 18.84. So that's actually the part of the circle that we want to use, 18.84. And then since it asks for perimeter, I'm actually going to erase all of this work because we don't need it anymore. Perimeter is just tells us to add up all the sides. So if we add up our red 18.84 plus the 2 12s that we're using on the outside of the triangle, let's see, so 18.84 plus 12 gives us a final perimeter of 48.84 units. And we are all done. So again, they might give us a complex shape like this, but if we can break it down into shapes that we know how to solve, right, like a triangle and a semicircle, we'll be able to solve it. So thanks for watching. Hopefully these examples helped. And if you need to go back and rewind and look at them again, feel free to do so.